All right, let's look at problem number 4. Listed below are the numbers in the internet users per 100 people and numbers of scientific award winners per 1 million people for different countries. Construct a scatter plot, find the value of the linear correlation coefficient, find the p-value, and determine whether there is sufficient evidence to support the claim of linear correlation between the two variables. Use a significant level of 0.01. Now keep in mind you're talking about slope predominantly when you're talking about a line, so that's a lot of what we're going to be looking at is the slope. First thing we want to do is to create the scatter plot. So let's open this up and we'll open up a new StatCrunch with it. So we've got our data and what we need is a graph. So we go to graph and we go to scatter plot. The X variable, the internet users per 100 and the award winners per 10 million. And we just compute and it gives us our graph right here. Okay, now look and see if you can find the one that is here. Of course, it's given its own measurements over here, but this is the only one that I see that has points kind of to the far right, like this. So I'm going to try D. Okay, so now I'm kind of through with the graph. I can just do this and I could get back to it or put it up there, or I could have gone ahead and deleted it. Now we want to do the same thing we've done before. We want to run the regression test for simple linear. X is the internet users, Y are the award winners, and we keep the intercept and the slope, but keep in mind the slope is what we're really concerned with here. Your R, your correlation coefficient, is here. Gave it to us 0.78, and that'll be 4. 0.784. Okay, then we kind of set this up. We've done it. Let's see if I can make this come up here. To get it out of the timer there. Okay. Equal and not equal, and those are to 0. Okay, now your test statistic, that is the t-value that's over here. We may have to move this over a little bit to be able to see everything we need to see. Now keep in mind, I told you we were talking about the slope. All right, this would be it right here. Your t-stat, 2 decimal places would be 2.53. It would round up. Okay, and then we get the p-value over here. It's the lower one too. We're dealing with the slope, 0.065. So it gave it to us the exact number of places that we wanted. Because the p-value of the linear correlation is compared to the significance level. Our significance level is 0.01. 0.06 is greater than the significance level. If it's greater than significance level, it is not sufficient evidence to support the claim that there is linear correlation. Of course, when you looked at that graph, it didn't look like those points were in a line anyway, did it?